Hi, this is Sam Michel, and I hope this could be either the last video essay about physics, or it could be the beginning of a whole new series of stuff. We'll see. We'll see how it goes. Potentially, it could go either way. It's similar to a previous essay called The Victory of Convention. This one is The Ultimate Victory of Convention. In my previous essay on GR at quantum scales, I made a single assumption that, if untrue, could vindicate conventional approaches and arm them, so to speak, with the sophisticated arsenal required for complete, accurate understanding of the quantum world. Now, that's quite a statement. That's quite a statement. And the statement was that I was assuming was true in a previous essay. Space-time is the same at quantum scales as it is at galactic plus. What if it wasn't? Could that explain quantum weirdness? Multi-state molecules, atoms, and nuclei? Near speed of light motions and rotation? It might. If the elasticity of space-time was greater at quantum scales, or much different than at galactic plus scales, it verily might. For one thing, it could explain why metastable nuclei emit a gamma rather than a micro GW. By simple analogy, it's easier to snap a rubber band than gong an extremely large bell. And I'm talking about like a bell that would take 20 guys to ring, a huge bell. There's some Japanese bells, like Buddhist, huge stuff. It's just enormous bells that would take a tremendous effort to gong versus, what's the, snap a rubber band is, cakewalk compared, right? You snap it. I'm trying to come up with analogies that would help us understand the difference and why it happens one way and not the other. So it's easier to snap a rubber band than gong an extremely large bell. A local large deformity can release energy as a photon much easier than a global small or uniform deformity can. So if you have let's say you're thinking about, you're standing on the surface of a neutron star in your imagination, and you got like a global deformity on the surface of the neutron star, which would correspond to a nucleus, versus a very limited spatially extent, a deformity right in front of you that looks like a little mound versus, topologically or energetically or releasing that energy, to me, would seem a lot more straightforward in terms of a photon than in a micro GW. Yet again. So a local large deformity can release energy as a photon much easier than a global small or uniform deformity can. It's easier to shoot an arrow than make an earthquake of low magnitude over the entire planet's surface. I like that analogy maybe better than the rest because it's easier to visualize. I don't know how you would make an earthquake, like a tremor over the whole surface, of a small planet, like a neutron star type of thing. All right, it's easier to shoot an arrow than make an earthquake of low magnitude over the entire planet's surface. So I'm trying to make analogies to demonstrate that why a nucleus emits a gamma rather than a micro GW. It would also easily explain global cosmic expansion at subnuclear scales, stretching only where it can. It might also lend credence to string theorists and multiple compactified dimensions, if space-time is more and more elastic as we zoom in or scale down, we shouldn't be surprised by exotic topologies at quark scales, or even smaller. The mirror sector may indeed complete the picture of the quantum world. We may, from my perspective, finally be on the right track after all. The ultimate victory of convention.